Okay, now we are going to talk about rational inequalities. Okay, so what are our rational inequalities? Well, they are going to be ratio means fractions, so they're going to be our fractions. So you're going to have some sort of expression on top divided by some sort of expression on the bottom. Okay, these as well have a standard form, and again, it's not that it has to equal 0, but you have to have a 0 on one side. Okay, so what are our rational expressions going to look like? Well, the parent function for a rational expression is our reciprocal function. Okay, so your rational functions are going to have a vertical asymptote, and they're going to have a horizontal asymptote. Okay, and our rational functions are going to look like this here. Okay, so again, we are going to be trying to find, or for our split points on this one, we're trying to find our split points again. So just like with our quadratic, the split points that we're going to be searching for are going to be x-intercepts. Okay, and we'll talk about how to find the x-intercepts. But this one has a different split point because you can tell on the left side it's above our y-intercept or x-intercept there, and then on the right side it's below. Okay, and it was the same thing when we did parabolas. Okay, on the left side it was above, right side was below, left side below, right side above. So we made our chart. We just had to find x-intercepts with that last one. But here, if I see to the right it's below, my other split point that I'm going to be searching for is actually going to be our asymptotes. Okay, so when we are doing rational expressions, you are going to be trying to find your split points, which will be your x-intercepts, and it will be your asymptote, okay, that we will be looking for. So essentially, if you get it into that standard form, let's say we have x minus 1 over x plus 6, okay, and I've got that it's greater than 0. I've got to find my split points, okay, which would be my x-intercepts. To find my x-intercept split point, all you do is you look at the top and you set it equal to 0, okay? In order to find my asymptote split point, I'm going to look at the bottom, and I set the bottom equal to 0. Okay? So, actually finding your split points on your rational functions is fairly easy if it's in the standard form. Now, if it's not in the standard form, that's where it gets a little bit tricky. But if we're in the standard form where we already have that it equals 0, finding the split points is as simple as setting the top equal to 0 and setting the bottom equal to 0. Okay? So let's go ahead and work through one of these, and we're not going to do the easy one first, obviously. So we're going to look at 4x plus 5 over x plus 2 is greater than or equal to 3. Okay? So again, just like last time, our first step is that we've got to get this into a standard form. So I've got to make sure that this equals 0 on this side. This side here has to equal 0. Okay? So your guys' tendency is to see this and want to try to multiply by x plus 2 to get that off the bottom. But we cannot multiply the whole thing by x plus 2. And the reason is we don't know if x plus 2 is positive or if it is negative. Okay? And the reason that normally it doesn't matter is normally we're dealing with an equal sign. Okay? But this one here we're not dealing with an equal sign. We're dealing with a greater than or equal to sign. And it's important to know if that's positive or negative, because if it's positive, nothing happens. But if it's negative, we'd have to flip that sign there, right? So since I cannot just multiply by an x plus 2, what I'm going to have to do first is I'm going to have to subtract 3 to both sides of the equation. When I do that, that gives me a 4x plus 5 over x plus 2 minus 3 is greater than or equal to 3. Or sorry, is greater than or equal to 0. My bad. Okay? Now, that is in standard form because I have a 0 on this side. However, this part is not in standard form because I need it to be a single fraction for it to be in standard form. So now, I'm going to have to get these two to have a common denominator and then combine them together. So the one on the left has an x plus 2. We need to get an x plus 2 on the right. Okay? If I do something to the bottom, I have to do it to the top as well. So I end up with a 4x plus 5 on top minus 3 times x plus 2. And then we have the x plus 2 on the bottom, so our common denominator is the x plus 2, greater than or equal to 0. Okay? A lot of you guys are going to forget to distribute the negative 3. You'll distribute the 3, but you'll forget that it's negative, so make sure you distribute a negative 3 into everything here. Gives me a 4x plus 5 minus 3x minus 6 over x plus 2 greater than or equal to 0. Scroll up. Okay, combine my like terms, 4x and 3x gives me just an x. 5 and negative 6 gives me negative 1 over x plus 2 is greater than or equal to 0. Okay, this right here is now in our standard form. Okay, I've got a single fraction and I've got a 0 on this side. Okay, so fingers crossed if you see this on a test, hopefully it's already in this standard form. Because like I said earlier, it's pretty easy to find our two split points. Okay, the way that we find our split point for the x-intercept, we find our split point for the x-intercept. Hold on, can I do a highlighter here? Yeah, nice. The way we find a split point for our x-intercept is we are going to set the top equal to 0. Okay, so I'm going to do x minus 1 equals 0, which gives me x equals 1. Okay, and that is going to be my x-intercept split point. Okay, scroll down a little bit more. I also, though, need to find my other split point, which the other split point is going to be where the function is undefined, which is an asymptote. And to do that, I'm going to set the bottom equal to 0. Okay, so my bottom is x plus 2 equals 0. Okay, gives me an x equals a negative 2. Okay, so two split points are 1 and our negative 2. Again, remember these are not our answer. To find our answer, we're going to need to draw our chart here. Okay, so I've got negative 2 and I've got 1. Okay, I'm going to divide this up. And then remember here, this is where we're going to go through and we're going to do our test points. Okay. Okay, so I can test in this section. What would be a good test point? We could do negative 3. In this section, we should use the best test point, which would be 0. And then in this section over here, it just has to be something greater than 1, so I could do 2. Okay, and I'm going to roll through and I'm going to check. And remember when I check, we want to check with the original equation. Just in case we made any mistakes or something, we definitely want to check with the original equation there. Okay, so I'm going to have a 4 times negative 3 plus 5. I'm going to check and make sure I'm right. 4x plus 5 over a negative 3 plus 2. And that needs to be greater than or equal to, right? Greater than or equal to 3. Okay, so I'm going to check this out. Negative 12 plus 5 over negative 1, greater than or equal to 3. Negative 12 plus 5 gives me negative 7 over negative 1, greater than or equal to 3. 7, two negatives make it positive. Is 7 greater than or equal to 3? True. Okay, true's the good stuff. Okay, and then I'm going to go 4 times 0 plus 5 over 0 plus 2, greater than or equal to 3. Okay, 4 and 0 cancel. I'm left with a 5 over 2, greater than or equal to 3. Some of you guys can look and tell that that's false. Some of you guys cannot. Plug it into your calculator and do 5 divided by 2. 5 divided by 2 gives me 2.5. Is 2.5 greater than or equal to 3? False. That is not. Okay, and then our last one with a 2. 4 times 2 plus 5 greater than or equal to 3. And on the bottom, we've got a 2 plus 2. So that gives me 8 plus 5 over 2 plus 2. I definitely could have added 2 plus 2. Sorry. That's 13 over 4, greater than or equal to 3. And then if I divide 13 over 4, I get 3.25 is greater than or equal to 3, which is true. Okay. Now, we need to go through then. Remember, we shade over our true sections. So it looks like we're going to have an or statement again. Now this time is going to be a little bit different, because if we look at what we have here, 4x plus 5 over x plus 2 is greater than or equal to 3. Greater than or equal to. Okay? So we are going to have a closed circle over 1. Okay? And I want you guys to remember, this is important. 1 we have a closed circle on because 1 was our x-intercept. Okay? Meaning that it is crossing that at 1. We are including that. However, -2 is an asymptote. Nothing ever crosses an asymptote. So we are going to have an open circle at 2. Okay? And this is only true for your rationals. If I was doing a quadratic and I saw greater than or equal to, they'd both be closed circles. But only for a rational. Your x-intercept would be a closed circle in this case. But since it is just, since -2 is an asymptote, we would not be including -2. And that's true. You will never include your asymptote. The number that is your asymptote will always be an open circle. It's only the x-intercepts that will change between open and closed circles. Okay? So our answer for this, we're looking over where our true statements are. We would be from -infinity to -2. And I'm not including -2. Obviously, we don't include -infinity. In union with 1, and we are including 1, to infinity. We don't include infinity. Okay, so that would be my answer for that split point there. All right, then if you guys we go back, we look at our graph here. Okay, you guys can see there is an x-intercept here. There is an asymptote at -2. Okay, so we were trying to figure out where was it above. So obviously this whole section here, it is above. Okay, but we're not including this asymptote. That's why I didn't include it, because it doesn't touch the axis there. Versus down here, you can see that this section is also above, right? But we are going to include this point because that is the x-intercept. It does cross in that section. Okay? Now, just kind of a quick summary. Just kind of a quick summary here, kind of tie it all together. Okay? Quadratic inequalities. Remember, both of these, and this is for both, we must get into standard form. Okay, the standard form for a quadratic is your ax squared plus bx plus c. Okay, and then greater than 0, less than 0, whatever, it doesn't matter. Okay, standard form for the rational is going to be some sort of function over some sort of function. Greater than 0 could be less than 0. Okay, so any one of those, we have to get them in the standard form first. Okay, for the quadratic, once I get into the standard form, we factor to find split points. And our split points are the x-intercepts for that. Okay? How do I find my split points over here for my rationals? I'm going to set top equal to 0, and that's going to tell me my x-intercepts. Okay? Remember, the x-intercepts are the ones that can be open or closed circles. Okay? And then I set the bottom equal to 0, and remember, that's going to tell me what my asymptotes are. Okay? Your asymptotes, something to remember, are always open circles. Okay? So this step right here, this is finding my split points. This step right here is how do I find my split points. Okay? That's all about your split points. Okay, that's all about finding our split points. Once you find your split points, you're going to set up your charts. Okay, and then you're going to test your points. Okay, and then the last thing, and this is again, this is true for everything, you are going to shade above your true sections. Shade above the true. Okay? Now, here on these other ones, I haven't really given you guys practice problems to do. I am going to give you guys practice problems on here. So there's 2 practice problems on the back. Get those done and have those ready for class next time.